Greetings everyone. In this video, we'll be discussing about the most interesting equipment in our substation, that is the current transformer inside city. Basically, this course is for the new beginners substation engineers, UG students who are interested for real-time power system, and technicians who are working or interested in grid substation maintenance. So in this video, we'll be having the introduction to CT, the different types of CT, the classifications, different parts of CT, the nameplate details, various terms associated with the current transformer, the maintenance practices, and at last the summary. CTs are basically the instrument transformers that are used to supply a reduced value of current to meters, protective relays, and other instruments. As we know, in our substation, in large power systems, a high value of current is being flowing in the conductors, so that cannot be measured through energy meters. We need to step down the value of the current through CT, and that can be helpful for other aspects also. So the CTs provide isolation from the high voltage primary and permit grounding of the secondary for safety and step down of the magnitude of the measured current. And the CT ratios are expressed as a ratio of the primary current to the secondary current that you must have studied in your theory classes. For example, a 300 is to 5 CT will produce 5 amperes of secondary current when 300 of amperes of primary current flows, and the current will be stepped down. Here you can see the application of CT as we discussed. It is used for the metering, protection, monitoring, testing, switchgear integration, but not directly through relays, through energy meters, through SCADA, through operators. The basic function is like the brain acts as the in our system, in our human system, biological system. The function of relay, the like the brain. Similarly, eyes, ears, nose, skin. That is the CT, CVT, VTs, potential transformer. Similarly, hand and leg are nothing but the circuit breaker and isolators. When we have the input sensing organs, that is our ear, eye, nose, skin. Similarly, the CT, CBT, PT, that acts as the sensor for the our substation, the value of voltage and current that are being sensed. Then it is being processed by the relay, whether it's normal or abnormal. Accordingly, instruction is given to the circuit breaker and the isolators for closing or opening the circuit. So all these functions cannot be performed without the in- involvement of a CT. That is, relay cannot detect the faults, energy meters cannot take the reading, SCADA cannot monitor the loading, and operators, energy operators, power system operators cannot access the system health. Next comes what are the types of CT available based on structure, based on service, based on insulation, based on tank design. So based on the structure, wound type, bar type, bushing type, core balance current type, ring type. Then based on the service, like measuring CT, protection CT, special type protection CT, dual purpose CT, single ratio, multiple ratio, multiple core, like that. And based on insulation, air support, dry type, oil insulated, SF6 field. Then based on tank design, dead tank and live tank. Here you can see one cross-sectional view of dead tank city and live tank city. When the secondary terminal is uh, at the bottom part of the city, and the oil is at the primary side, and when we have the live tank city, the oil and The primary winding, as you can see, is there, and the nitrogen valve, oil level indicator, tank with cover, the clamp, pressure release device, everything you can see, that is for live tank. And for dead tank, the application of live tank and dead tank is based on the voltage values and design considerations. Here you can see on the right hand side a 33 kV city, that is the voltage level is at 33 kV, and all the three phases cities are live tank cities. And on the left hand side you can see 132 kV city, and they are dead tank cities. So what are the function of primary conductor? It carries the system current, that is the high value of current. The magnetic core produces the magnetic flux similar to our transformers. Secondary winding delivers the scaled current, the step down current. The porcelain or composite insulator provides insulation. Terminal box, it is used for the secondary connections to the equipment we want to connect with through the console box, city console box. And the insulation can be oil or HF6 for insulation as well as cooling. Here you can see in the picture the inside the tank how the secondary terminals are there in the light tank city. The cores, and here I have taken one of the photo for a nameplate. The ratios are mentioned 400, 200, 100. Three cores are there, and 400 by 1, 200 by 1, 100 by 1. Based on our primary current, we can select, and the secondary ratio is 1 ampere. If primary current is 400 ampere is flowing, then we can get 1 ampere in our secondary side. So here you can see the burden of the city, the class, the accuracy, the frequency it will be operated, year of manufacturing, company name, weight of oil, weight of city, and the customer, the value of knee point voltage, and secondary resistance, and the date of manufacturing and order date based on which the equipment has been procured, and the serial number. So these are the essential data we need to have whenever we are going for the installation, commissioning, operation, maintenance, and testing purpose. And from the nameplate also you can get the values. Now the common terms are current ratio error, phase angle error, composite error, and accuracy limiting factor. These have been studied in your theory classes, and I'm not going to discuss in detail about the errors and the limiting factors in CT. So, as we know, this is like the very much up resembles with our eye. So, we should take care of the input sensing organ, and the maintenance schedule is there. First is the porcelain part, the insulating part should be cleaned from dust and pollution, and the tightness from the primary winding, primary the conductor, that should be clamp, the jumpers, tightness, not bolt supporting structure, everything has to be checked. Then the foundation for any crack or any dysfunction, and the oil the oil level indicator is there, and we should check if any abnormality is there in the oil, and oil leakage is present or not once it has been taken into service. So this is the conclusion, that it plays a very very important role in the metering and protection part of the substation, and other relevant details will be discussed in the next videos. Thank you for your patient hearing.